Yeah, thank you very much. So let me introduce myself once more. So my name is Peter Kiptanui. I'm a DevSecOps Engineer at Safaricom. I have been practicing for 2 years and a month now. Yeah, and I'm glad to sort of like share with you what I do on a daily and probably maybe, yeah, what it all entails and how you can prepare yourself for the same. So if you want to transition or you want to build a career around DevSecOps. So I think I'll start. I'll share my screen because I have a presentation. Let me just share. See where the screen is at. Okay, so it's a masterclass on. Maybe I'll call it DevSecOps. I'll infuse a sec in between so that you'll get to know why I have done that, because we have morphed as a technology from what I'll explain to where we are right now in terms of that. Yeah. So we are going to start. So what is DevSecOps? But before we get into DevSecOps, as I mentioned, we need to go back a bit just to understand before we get into that. So before DevSecOps, there was DevOps. And just one step back, yeah, before DevSecOps, there was this thing called waterfall, right? So you would see like like until just before the year 2000, we used to have we used to have this like software development and updates where were being made by this thing called a waterfall methodology. So it was like a linear approach to large scale project. So this means, like for example, you would from the beginning of the analysis to the point where it is actually implemented and deployed, it would take like maybe even 6 months or 1 year. And that means, for example, if for example you are developing something and then that thing sort of like was overtaken by events. For example, you are developing, I don't know what example to give. For example, just think of it like maybe you are so focused on creating an SDK implementation that is GSM based, and then maybe the GSM was phased out, and now guys are in maybe 100% internet. So that technology would have maybe been phased out even before you are able to to deliver that product. And it had a face, it had like certain faces that were clearly marked out and cut out. So you would start with, for example, you would start with guys just like building large codes, and then after you do the chunk big code, you would then hand it over to the QA, and then security and operations team would still spend more time testing and in sort of like validating that this particular software is good. And then so the result was like months or even years were spent in between releases. Yeah. And then there was this big sherehe, like a big bang period where we are launching this version 1 of a product. But behind that, you have actually literally spent like 6 months before this particular release was done. So, but like there was a problem with this sort of like methodology, right? So to speed up development and improve quality, so the development team began adopting an agile software development methodologies, yeah, which were iterative rather than linear. So as is so far, the waterfall methodology was linear, like it is a line. Like even if you see at my presentation at the presentation, you would see it's a line with I think a negative gradient, which means it's a linear function. It's like it's a line, but then there was a move or a shift towards agile methodologies. So agile methodologies, like one of it was the CICD. And maybe I don't know if I may go to the next stage. So yeah, so one of the methodologies of the agile was the CICD, and the CICD sort of broke this linear into an iterative. So an iterative, you can look at it as a cycle. So a CICD is a sort of like something that repeats itself in iterations, small bits, and there was a velocity now in this. So instead of those 6 months, smaller chunks of new code would emerge, after every say 1 or 2 weeks. So if you look at the agile methodology, normally we have things called sprints, and in those sprints there is a deliverable, a small shippable product that would be shipped at the end of that sprint period, which is normally like 2 weeks or 4 weeks, depending on the cadence that is being agreed by the organization. So the important thing about CI/CD is different teams would work together remotely. Like say, for example, one would work, for example, in Nairobi, another one would work in Eldoret, or they would work in different maybe departments or organizations, and then they would all do their coding, and then their changes would have to be integrated now into the what we call like the trunk of the project. So like you would have, if you look at it as a tree, you would have maybe different branches, but they all would come back to this particular trunk. You think of it like this. So for example, if you're creating an app, and say for example, there's one who has taken the task of creating the login functionality, and then there's another one who's who's maybe taking the notification capability, and then there's another one who's taking care of, for example, payment function capability. So all these, they don't need to wait like for this person to finish so that I can jump on this. No. What we do is different team members would work on their different features, but then they would integrate their code. And we don't have to wait, like in the waterfall, for the code base to be so large for us to come now and start, cherry picking, for example, this one actually, he messed up maybe the name of the variable or something like that. So this integration is what we call now the CI part, the continuous integration. And these smaller chunks of new codes are merged into the code base, like say after every 1 week. And the key thing about now the integration phase is automated. So we have automation tools that would enable us to do this integration. So you would build, and then you would test, and then if the test goes well, then you would merge it to the trunk, to the main, or the main branch, or that trunk. And so that is speaking to just the CI part. And then so the more effective. So here, remember, we are curing the issue of large code base, as well as like the time we would have to spend before a deliverable, like we can ship something to the customer. And this is, I think it speaks now to the customer. But we're going to look at the whole agile thing is you listen to what the customer wants, and then you take that feedback, and then you come to that. But we'll get to now the DevOps that then went further than this. So as much as the CI/CD was effective, it had some bottlenecks to it. But even before we go into now the solution that DevOps now presented, we can probably maybe just look at what is this CI/CD, what is the CI part and the CD part. And actually here I'm giving you like these questions that maybe even be brought to you in an interview, even as you prepare maybe to jump on board the DevOps career line. Yeah. So we have the continuous integration and continuous delivery, or some say continuous integration and continuous deployment. But delivery, let me just to break down. Continuous delivery is you have a shippable product. It is shippable, but it has not been shipped. Like in this case, we can say, for example, if you have a cloud native implementation, it would mean that by the time you're saying you are ready to deliver, is you have actually built a Docker image that is ready to be then deployed to, say, for example, a Kubernetes cluster. But you've done actually up to the delivery side. It is ready to be shipped. And then the continuous deployment now is the actual the actual deployment to production. Now it is running on a server. So maybe that is that. Maybe if I may speak on it. So continuous delivery usually means the developer changes to an application automatically back tested and uploaded to the repository. That is just to the level of delivery. You've just placed it on the repository, like for example, an ECR, or even the Google image repository, or what other repository do we know? Yeah, for example, GitHub, sorry, Docker Hub, if you may posit your repository there. And then the deployment now has been addressed, is now the actual pushing of that code. So it is possible for CI/CD to specify just the connected practice, and then in the end, it is probably, it's sort of like helps. That automation means that you are benefiting from a standard way of testing your code. On the CI/CD, you can actually also look for example, sanity checks, and this actually meant that the code that is ready to be delivered, or it is shippable, is actually secure, and it has, for example, less technical debt, because, for example, you've done your code coverage, so like you have tested all your methods, all your functions. You have unit tests for each function, so it can't break something if you do your regression tests. So I think that speaks to the continuous integration, continuous delivery. But as I was mentioned, the CI/CD didn't go fully. It didn't solve full the development life cycle bit. Yeah. But before I go to the solution, to the improved solution that was brought after the CI/CD, I think if you listen to most DevOps engineers, they'll tell you the DevOps is mostly about processes, tools, because there's a lot of tools that we use as DevOps, and most of these tools are actually found within this CI/CD bit. And I think maybe I can just spend a minute just to speak of the tools that we have, and maybe you can listen keenly, so that maybe after this, maybe you can try out these tools, because most of them are actually open source. So there is a tool. One of the most common tools is, right now, the software version control, or the source code management tools, like, for example, GitHub or GitLab. They have now embedded they have now embedded CI into it. So, like, for example, if you go to GitHub, you'd see they have GitHub Actions. If you go to GitLab, they have GitLab CI. So these tools that initially were just meant for us to version our code, which maybe we may speak to the benefit of that. They also have now, as part of that product, they have a CI capability. So the continuous integration means, for example, and maybe I'll show an example later, is when a developer, for example, pushes that code to, for example, GitLab, it can automatically trigger a CI job that would go through stages, either the sanity checks, or even maybe security checks, and then that is now before it can actually be merged. So, and maybe let me just speak maybe of how it happens now in the professional world. So normally, if, as I mentioned, I think I had alluded to this earlier. So if you are developing, for example, that payment feature, and then you want to integrate it to the trunk, or to the main branch, you don't actually develop on that branch. So what you do, you check out of the main branch. So you check out, you go outside, you create your own branch, and then once you have done your development, and you have tested it on your local machine, for instance, you can then decide to do what? To merge it back to the main trunk. And before you merge, you have to raise a merge request. And in the merge request, automatically it kicks in a CI, so that it checks, is there anything that is sort of like breaking before we can actually merge this. So first of all, it'll run to see if it actually builds, because it means like this project it's able to compile. So there are no like syntax errors, so it is able to build. And then once it is able to build, it can run the unit test to check like you have not broken any functionality in this code base. And then, yeah, from there, probably maybe you can then for example, if it doesn't have any vulnerability, for example, you have not included a new dependency that sort of like exposes this software to hackers, for instance. Then after it has gone through all these stages, which is now accommodated in our CI, you haven't done the CD bit yet. So if it passes that, then ultimately as a last stage, you can do what? You can then package that and make it ready to be shipped to production. So the packaging there mostly is usually you doing, for example, if you're cloud native, and I'm biased towards cloud native because that is the feature, you would then build a Docker image. Maybe we'll speak of containerization and cloud native maybe at another forum. But then you would build it, and then you will push it to your repository. So it's just staging there. It is there. It can then be deployed, but it is sitting at a particular point. So that I have just spoken about, like the whole CI/CD cycle. But even as I have mentioned about that, so far you've had me speak of the CI tools, like for example, GitLab CI or GitHub Actions. So there are others and more sophisticated product, especially now the CD part. Maybe I may just highlight Spinnaker as one of the tools. If you are tech savvy, you would know Spinnaker was actually made by, I think it was Netflix. And then there's another one called, there's GoCD, I think there's TeamCity. There is another one called FlaxCD. So you can maybe just look at this, because I've told you DevOps is mostly about tools, processes, and people, right? So you can familiarize yourself with these tools, because these are the tools that you're going to find in the workspaces, right? And then familiarize yourself also with Git, because it starts there. So if you're a software developer, you may be so good at software development, but do you know how to co-create with people? Do you know how to collaborate with people? Do you know how to, for example, use Git? Yeah. So Git is really a primary tool in terms of DevOps, which we are coming to. So the more effectively these agile development practices accelerated software development and delivery, the more they exposed still silo IT operations. System provisioning, configuration, acceptance testing, management, monitoring. All these were done in silos, right? So you can imagine, you as a developer, you have built on your local machine. What is the next logical step you want to do? You want to ship this thing on a server. So there's a team that is supposed to provision you the infra. They're sitting on a silo. And then again, you have a team that is also supposed to do the monitoring for you, or to do the acceptance testing. And all these people were sitting in silos, including the monitoring and the ops team. All of them were in the silos. And it used to be like you would finish coding and then you would throw your code over a wall for the other part to meet. And here I'm speaking of two distinct parties in software development lifecycle. So there was the devs, who we know code, and then there was the ops team. And these two people were working separately, and they're working in silos. And as much as agile or agility brought about this iteration, and we were now moving from 6-month deliveries to 2-week deliveries, or maybe 1-month deliveries, still there was some bottleneck that the developers will churn out features, but once they churn out features in 2 weeks, it takes them another 4 weeks for them to be deployed, for them to get to production. Why? Because I have to pass this to a QA person. The QA person has to pass to the security person, and then we have to provision for you the infra, and then the ops guy have to make sure that you have done you're logging correctly and whatnot. So there was a bottleneck, and the bottleneck was brought about by the silos. So then, as things evolved, we now came to the DevOps. Yeah, and the DevOps sort of like tried to mesh these devs and the ops through a cycle. Like you can see, like it's an non-ending cycle. And what is happening here is we have we now have like stages or phases in the DevOps, and we call it the DevOps cycle. So we have so normally it will start with the plan. So at the plan is where, for example, the business will sit down and say, what is the problem that the customers are facing right now? What are the opportunities that we have? And then we then agree with the team that, okay, there is for example, there's a problem. I want to, for example, to enable customers to buy maybe KPLC tokens. And then they agree, okay, the channel is going to be maybe USSD. And then they get the developers, and the developers do the integration and everything that they code. And then once they code, we have to build. You remember, like most codes you have to compile, and then you have an artifact. For example, if it is Java, you can build a Java application, and the artifact that you get is a jar file or a WAR file. And then from the build, you have to test. And then from the testing, if it passes, so here is where you have your quality checks or your quality gates. If it passes the quality gates, your product is then released. And in releasing here, we mean it is pushed to production. And then Once it is pushed to production, it is released, sorry, it is ready, it is shippable now. It is now on the ECR. And then from the ECR, which is, sorry, like this is a container repository, right? Or an image repository. And then once you have your container, once you have your image, you can then deploy that. And then once you deploy, the life cycle of that application does not end there. Remember, a software is a living product. Yeah, it needs to be operated. It's like food. You have to, you have to. It's like plants. Sorry, you have to water them. You have to prune them. So the same way. Here you have to provision. At times it will expand. So your infra has to be elastic. For example, so here in operations you can think about, and maybe I'll just speak of what. Maybe just let me go. From here is where guys really know us, from the release stage. So us, what we do, from the build, remember from here, we are doing it, we have automated this, the build, we have automated the test, we have automated the release, right? And also the deployment, we have the CD tools. So the CD tool will come here, the continuous deployment tool will kick in here. And then here, we do so on the operate is where, for example, as a DevOps engineer, right now that I told you, we are more cloud native these days, you are going to have your software mostly deployed to cloud. So on the cloud, as I'm talking about operate, you have to have your infra being elastic. Elastic in the sense of, for example, in Kenya, we know, for example, traffic peaks at 5 a.m. Say 5 a.m. and then at 5 p.m. as well, maybe to 8 p.m. And maybe there are certain things that we consume on the road that maybe the demand will go higher around those times. And you want your infra to be able to be elastic, to expand when there is demand and to contract when there's low demand. So here, if you're looking at, for example, the cloud, for example, let me take the case of AWS. This is where you have to set up things like, for example, a target group, or like an auto-scaling group, for instance. So in terms of target group, I'm talking about, for example, if you have a load balancer, you need to have a target group that has, like, servers in that target group, that the load balancer can actually load balance that traffic to the individual servers. And then you have an auto-scaling group, so that target group actually can grow or shrink depending on the demand in the market, or maybe you schedule it at a given time of the night, shut down certain servers. So this is what the DevOps actually work on. And then there is monitoring, which is really key. You ought to monitor your code. So there's application performance matrices as well as the infra matrices. Yeah. So even as a developer, you have to log your code sufficiently. You have to sufficiently log, because it will then enable the teams or the DevOps now to be able to maybe create monitoring.
Once a day.
If you're using Elasticsearch, you can create monitoring, and then you can create an alert based on that monitoring. And then here you would have things that I've mentioned, maybe Elasticsearch, you can have Splunk, you can have Datadog. So this is those tools that apply at this particular point. And then from the monitoring, actually, you can say, whether the customers really, this, for example, this feature is actually crashing. Yeah. So in the next iteration, we go back to plan, and then the feedback from the last release is fed into the sprint items for the next sprint. And then the developers keep on building, and the product matures with time. And yeah, it grows. Maybe there's a new framework you have to adopt to, and it changes like that. So it's a never-ending cycle. So DevOps outline a software development process and an organization culture shift that speeds the delivery of higher quality software by automating and integrating the efforts of the development and the IT operations team. Yeah. And here, remember, there's a culture shift where right now, if you go to certain organizations, you'll hear people speak of, you build it, you run it. You get, like, you build it, you support it, for instance. Because initially the developers used to develop, and they wouldn't care whether that thing will crash in production or not, because there's a team that is catering for that. But in this new dispensation of the DevOps dispensation, you'd find, like, you build it, you maintain it. The same squad in an agile setup, the same squad have to own that particular product end to end in its entire life cycle. So you have to integrate these efforts from the dev, the devs and the ops teams as well. But then, so what is DevSecOps? So the DevSecOps incorporate security like in every step of the software development. From the time you are in your IDE, we recommend that you have plugins that can be able to scan your code. This is an effort that is termed shifting left. That is a jargon in the DevSecOps space. Shifting left. We are pushing security left. Remember, security was left to the right end of that spectrum of the software lifecycle. But right now, DevSecOps advocates for you having these security best practices from the dev side and in all the phases, whether you are building, whether you are testing, whether you are releasing, whether you are deploying, whether you are monitoring, all the way. We need to have security in those particular phases. And maybe just to illustrate that, we have a diagram here that best illustrates that. So you can see we have planning, development, integration, deployment, operations, and then the learning. But in all this, there's a gray bar that cuts across all these phases. And that is very key. And the benefits of DevSecOps is actually, one of it is observability. That we are able to observe, we are able to observe, for example, we know how our systems are performing. We are able to know what code is actually in our servers because we have version control and stuff like that. And then we also have traceability. And in traceability here, we are able to trace the changes that are happening. Or for example, like we can actually tell what caused what. We can actually just trace maybe the genesis of a problem. So in most cases, you're going to have in case of an incident, you're going to have this root cause analysis. Yeah, if you set up in a DevOps, in a DevSecOps like sort of like framework, yeah, or methodology, you are going to have the traceability to tell, okay, this person did this push, and then it had the impact of causing this other system to go down, and you can actually just trace that and have your RCA done. And then there's the confidence. You would have the confidence to know exactly, for example, what Java version do we have running on our servers. For instance, if you're asked at any given point, you would have the confidence to own, because remember, everything is version control. So we have the version control, and then the building, the testing is automated. So we have the confidence that this one actually went through these stages, the sanity checks, the security checks, and we have a secure, in a bug-free software in the cloud, for instance, if you've deployed it to the cloud. And then we can actually also enforce compliance. Remember, there's a stage that we have for testing, and also for, like, when you're trying to integrate. Remember, before we can integrate your code to the main branch, we can run a CI job that has stages in that. And these stages can enforce the compliance. Say, for example, we can actually just set a regex. For example, you can say, if, for example, you are building anything, for example, if you're doing like anything maybe below Java 8, we cannot build, because even our tool doesn't even support compilation of Java, for example, 6. In terms of compliance also, we can say, for example, if, for example, you are deploying to cloud, we can put some compliance, for example, that this particular container cannot run with sudo, right, with the root user, for example. So these ones, you can actually nip them. You can actually just enforce this compliance in your jobs, right? And then what are the use cases for DevSecOps? I know this majorly just speaks to the corporation, but you can just stretch your vision and see why should I use DevSecOps? Why not just once I'm done, once it runs on my local machine, let me just push it to production, and you don't even use Git. You don't even have a CI bit. You don't have a CD bit. You don't have monitoring. So why? If you go that way, you would have lack of visibility. You wouldn't know what is deployed where, because it'll be based on your memory. for you to tell what is actually deployed, for example, in our cluster. You wouldn't know, but if you have DevSecOps, you have the code sitting in a version control, and you in a version control system, and you're able actually to have a visibility of that. You would have trouble auditing. You wouldn't know who pushed what code where. You wouldn't know, for example, there is something in DevSecOps called SBOM, so you wouldn't even know what composes your software. For example, you don't have like a software bill of materials to show, actually this particular software was built with this and that. Yeah. And in terms of unified governance, because everyone will do their own thing. Everyone will do their own thing. There won't be any governance whatsoever. So, for example, we've all agreed we're going to use, for example, a specific tool. And if you don't have DevSecOps, there's no way of enforcing this. So everyone will be doing whatever they want. If, for example, we say we are not, and this actually goes to compliance, for example, we are not going to admit any code to production if it fails as, for example, code coverage below 70% or 80%. Yeah. And then in terms of risk mitigation, you can actually nip out risks early enough. So you can mitigate before it goes to production, before it costs you millions. You can actually just mitigate them if you have implemented the DevSecOps. Yeah. So DevSecOps promises you security, secure by design, continuous security consulting and testing, and then continuous refinement. Yeah. There are industry standards organization, like for example, OWASP, which is the Open Web Application Security Project, which has software assurance maturity model to address governance, construction, and even recommend secure coding practices, like the 12-factor app. And in the journey towards DevSecOps, obviously you won't start day one. Like I wouldn't expect you, for example, to day one start from coding to understanding, like, for example, a tool, like for example, Flaxid day one. No, it is something like you build slowly. So you start maybe by GitHub. At least you version your software. You version your software, and then slowly maybe you would get to a tool like, for example, the CI bit. Maybe you now start playing with GitHub Actions or GitLab CI, and these things are actually free. So you can start playing with them, but you keep on maturing. But then actually this presentation, the particular image that you see here speaks to an organization as to how they can maybe learn from or follow the principles established by OWASPs in terms of how to best secure your application. So I guess that brings me to the end of my presentation. But the DevSecOps is all about a holistic, secure by design approach to code and delivery. And it all involves people, processes, and tools. People, we need to shift their culture, that they need to understand that we don't need to have these silos, like you are an expert in this, and once I'm done with my code, I then have to pass it to you, and then you are a higher authority, and you will tell me, no, I cannot deploy this code. It has, for whatever reason. We just we break those silos, and we implement DevSecOps as a merge of both the devs and the ops team. Yep. And then it is about processes. So processes is like the way you would do a checkout, the way you would do a merge request, the way you would employ a git flow, for example. Yeah, the way, for example, you would need to have approvals before it goes to production. And then in terms of tools, DevOps is about tools, and these tools are there to automate. You can imagine if right now we were still plowing our farm with our fingers or our hands. We needed to have tools, and these tools sort of like make our life easier as DevSecOps. And here we're talking about toil. We reduce that toil. I don't have to assess your code line by line to get the code coverage. No, I can actually have a tool that can do that for me and report back a result. I don't need to scan, for example, vulnerabilities in your code by going through, I don't know, a list of vulnerabilities versus what you have. There's a tool that can do that for you. And the best thing about DevSecOps, or what it actually tries to achieve, remember, it is established in Agile. Back there when there was CICD, it is about the velocity. of our releases. How soon can we present a product to our customer, creating that value to our customer, and falling fast, knowing, oh, okay, the customer doesn't like this, let us change this thing real quick to meet the customer needs. Yeah, so that is my parting shot. I have spoken for a very long time, but I think that is it. I think I had prepared some questions for you guys, but I don't know, maybe I'll leave this with the team. Let me maybe just stop sharing that. Let me just share holistically my screen. I wanted to show some things. I can't dive into a project, sort of like a demo, but just maybe just showcase to you what we normally would do. Coding. Let me start from coding, right? So if maybe, for example, you're a software engineer and you create amazing solutions through code, you would have your IDE, and as I mentioned, I think most IDEs would have a provision for plugins. So you can have a plugin that can maybe SonarQube as one of the tools for you to check your sanity checks, and also maybe code vulnerabilities. And then what I wanted to showcase is always so in DevSecOps, we want you to have a version control system. So like in this particular case, I have a repo here that, for example, if I were to make, maybe for example, actually, this is a hard-coded objects, but for example, if I were to change, for example, the color to maybe purple, yeah, and then I would have to commit this particular change. I would add, and then I would commit and learn this particular git command. Very simple, but they're important. And for some reason, I could not push this, but I'll speak as what it means. So I could not push this code. Let me just say origin main, I think. Yep, let me just say main. It will ask me for credentials, but for some reason it is refusing to take my credentials. I think, yeah, I tried it to refuse to take my credentials. Apologies for that. But then if you're able to push this code, remember it goes to GitLab. So for example, this is your GitLab, and then on your GitLab you would have this. This is now that repository, and then you would have maybe key things. I can maybe just mention these items to do with, like, for example, the commits. How many commits have you been making? Like, say you can see me, I've been making commits to this demo project. So this is what we call, like, that traceability. We can actually trace when did this product start failing, which commit did you do. And then you see now me here, I was adding, like, for example, I've added a color here. I was doing a merge from dev into main because I'm promoting what changes I've done in development to main. For example, if you go to a specific commit, I think, so you can actually see what changed in this particular commit. What change did Peter do in terms of that traceability? Maybe just let me go here, for example, just to indicate one, and maybe just to show you, you can see like what sort of like changes. So the ones that are old is minus minus, the ones that are new are plus plus plus. So you can actually see the changes this guy made. And if, for example, someone issues you a merge request, you should be able to evaluate as a senior developer, for example, in the team, and then if it is okay, you can merge it. Let me, for example, and then I had spoken about branches. So the branches, like in this, I have two branches. But as I mentioned, you can actually, from the code base here, maybe if you can run a command, for example, git remote, remote, and then version, git remote b minus b. You can check what is your origin, and then maybe you can do a git status. These are simple commands that you can use, but you can see now the branch I am on branch main right now. But so if you want to maybe check out into a new branch, you can check out maybe, and then maybe you have a feature that you're developing, and then, for example, payment. Check a git checkout, sorry. So I have to git checkout. I want to go to this branch. Yeah, you see now I've switched. I don't know if my screen is visible, but I have checked out to a new branch. And if you are to push, if you switch the original, you can actually push to this and then raise a merge request. But the idea is you can actually always, it is best practice that you check out to your own branch, work there, and then you can delete that branch once you're done with that feature. So let me just go through maybe creating a branch. So for example, if I was creating a feature branch called payment, and then I can create that branch from the main branch. So you from the main trunk where you are at, and then I talked about maybe creating a merge request. So you can create a merge request. Say for example, you've done your changes and you want to merge again back to the master. So you can see here, you can merge from for example, the FT payment. Now you're merging it to main, or you can probably maybe merge it to develop before you can actually promote it to from develop to main. So that is the sort of like the git flow that I was saying. So you can assign me, I can assign myself, and I want to delete this branch once I have merged. So once you create a merge request, the developer who's been assigned will get a notification, and they can come and approve your the merge request. So right now it's opening here because I am the person who's assigned myself that particular thing. So I can decide to merge, and if I merge, the changes that I had done on that particular branch would go here. So if you find time, I think maybe I am about to burst my own time. You can look into the CI/CD. So where I had talked about the pipelines that you can create that can be able to do all these steps, and there is a guide into, you can use a template from either of the major languages that you have. Say for example, me, I have a bias towards Java, sorry, not Java. So okay, let me see. I think there's a Marvin project. They want me to type Marvin. Yeah, so there's a Marvin project. So as a Java guy, I would go for Marvin, and then you can use this template. I think now let me just maybe showcase a last item. So there is another tool maybe I can just showcase today, not really deeply. There's this tool now called Jenkins. This tool also I'll recommend, you can play with it, you can download it. It's open source. You can download it so long as you have Java in your machine. It's a Java-based application, so you can run this thing. So like Jenkins here, I have set this Jenkins is a CI tool. Some use it as a CI and a CD tool. So basically, this Jenkins, you can associate it with your Git, with your GitHub, for example, GitLab or GitHub. So for example, let me go to this particular item, or so this item is actually a GitLab project. So there are a lot of plugins also that you can add here. So this one is a multi-branch. This is a multi-branch project, and maybe what I can showcase to you is, if you look at the configuration, and maybe this is just to spur your interest in DevSecOps and how these automation tools come, just to provoke your thoughts, and maybe you can just pick this tool up later. So in this case, I just give it a name on the configuration, and then you can see here, I am connecting it to a branch source, which is now GitLab. So it's a GitLab project, and I am using the default gitlab.com, sorry, and then I have to pass my credentials. So here I've done a personal access token, and then the owner, so the owner is, if you look at my GitLab, everyone's GitLab. So for example, if you go to GitLab, my username is OneCoach, and every of my project would be GitLab/OneCoach. So this is what it means by the owner. So the owner is OneCoach, and then it should be able to scan and see what projects do I have here. You can see I have projects in that GitLab. So you can select the one that you want to integrate to have the CI bit done here. And then after that, you just be asking it to be polling. So you specify where your Jenkins file is. Sorry, I hadn't shown you the source code. So there's a bit of effort that now the works that I had mentioned what works we do as DevOps engineer. So as we create these pipelines, and I don't want you to leave this without me speaking about a pipeline. So depending on the tool that you're using, different different projects have different tools. Sorry, different projects use different CI tools. So in my case, I'm using Jenkins. Yeah, Jenkins is where you describe your pipeline, your CI pipeline. So the first thing that I do is I check out the code, and then so this is where the checkout will be done. So checkout is like you cloning, so to speak, the code into the Jenkins workspace. And then from there, you can run this command. Like for example, you can maven clean, and then you can maven test, and then probably maybe you can package it, and then after you package it, then maybe you can have this stage to do your sanity checks, and maybe also show you a bit of vulnerabilities that you may have. So this is a SonarQube. There's a SonarQube server that you have to connect with. Again, pick out that name, and then from there, you can assess the quality of your code, and then you can then do a Docker build, and then you can do a continuous delivery. Up to this point, you are pushing this to your ECR, and then that's it. Probably maybe I'll share this with the team so that maybe you can just look at it and maybe also learn from it and maybe build even more superior code. So this Jenkins is of concern to this project. So you have to specify that the script path where the job will run from is going to be this Jenkins file. And you can see I have named it as such. It is Jenkins file. That syntax is quite important. And then it will periodically also try to scan to see if there's any change in that. And if there's a change, it will build. Now, right now, it will fail because I am not, remember this is running local. I have not started, I forgot to start my SonarQube server. But then how does it look like when it is triggered? So let me just, you see now it failed because the SonarQube, I think this one is sorry, let me go back. So this one is an example of a successful build because it's all green. And these are the stages that I was talking about, where you can have your governance, you can have your compliance in the stages within the pipeline, right? So basically, this is what we do, and all this is actually automated for you, you know. And yeah, so that is, I think that is it. Maybe just to showcase to you, there is capability where you can actually so maybe someone may ask, how does this Jenkins connect with the Jenkins file? It is through technology called webhook. So whenever there's an event, there is a webhook that is triggered that is then picked by Jenkins. So maybe I can just show you under my settings, under webhooks, you will see like I have 2 webhooks right now. And even if you're at home and you want to connect things that are not in the same, for example, network, you can use ngrok to just play with it. So here I have this, and if you see my ngrok is exposing port 8080. Sorry, you can't see my command. So I'm actually exposing port 8080, and the reason being is because my Jenkins is running on port 8080. So that means, for example, if you're to test this, it's actually the 62 one. So if you're to test this, you can push an event and then it will tell you like, yeah, there was connectivity. You see it's 200, right? And if I make a change right now, as I had done, so for example, if I come to the project and then I make a change, for example, just let me just even change maybe the readme. I just delete the readme file. Let me just not like maybe just delete this line and commit. So I'm doing with the UI. And then so if I commit that change, if the webhooks kick in, you would see it will trigger a job. I think this is in which branch? Let me see the branch we are in. So right now we are in the main branch. So we are guaranteed that if you go to here, the main branch, you should see it trigger a job. You see it's pending, and then 42 will kick in immediately. You see it started building. So that job already starts, and that is how we do. So long as you're a developer, you push it to your GitLab immediately. It is picked by your CI tool, and before we can actually say, for example, integrate, the jobs will start running, yeah, and then ensure that that code integrates well with the already existing trunk, or the trunk of that particular project. So I think by and large, I've spoken about the rudimentary tools that we use. So you can check out Jenkins, you can check out GitLab CI or GitLab just for your version control, and then learn your your Git commands. And then maybe let me just speak on an overview. So mostly right now, you'd find like most companies are going cloud native. So you also need, for you to fit well in the DevOps space, you need to have you need to start playing with cloud native tools. For example, Kubernetes, Docker, containerization concepts and stuff like that. What else? Yeah, so those kind of things. And for that, we have tools. So right now, you can actually have your tool. Like for example, there's a Docker which you can use. You may have it. It is quite handy at times. So you can play with the Docker as is by itself, and then you can actually enable the Kubernetes feature of Kubernetes, or you can use Kind. Kind is actually Kubernetes in Docker is actually Kind. So you can see here, I have Kubernetes Flux running. So Flux is the Flux CD that I was talking about. It's a CD tool. So you can play with this. Yeah, and then what else? What else? I think, yeah, I think with this, I think maybe you are initiated into the world of DevSecOps. At least you know what I do on a day-to-day. And as I mentioned, the value is velocity of release. And you can imagine, if you're in a large organization, you cannot be approving you cannot, so for example, approving deployment one person. You automate this tool, people do their deployments without human intervention. You're only called upon should things fail. And DevOps is about people, processes, and tools. I don't know if that has been beneficial. Maybe pass it back to you, Marilyn.
Thank you so much. That has been very beneficial, and now I am hoping that everybody who is in the session will appreciate that development goes beyond just writing code. There's the security aspect that has to be taken into account. So yes, there are many people or tools that are involved between the initiation of a project and deployment phase. If anybody has a question, it would be a nice time to shoot them to Peter. You
Yeah.
can mute or type on the chat, and then he can answer. Peter, you can also
Yeah.
share social so that anybody who wants to, to reach out to you can do that.
So there was a question: what makes an application cloud native? Yeah. So if you go to cloud native, of course, the master, like one of the most indispensable tool in the cloud is an orchestrator called Kubernetes. And if you look at Kubernetes and the whole, let me just call it family. It has there's a small unit of it called I think the smallest is a pod, and a pod can have multiple containers, but a pod is small. The issue with our cloud native application is an application that can easily lend itself to scaling horizontally, right? And if you look at that, it is the genius of it is having small system, but you can have 200 of them, as opposed to having one large system that you can only have 2 of them. And so your application has to be small, And that speaks to something called microservice. So you have to create, don't have an application that is, for example, 400 MBs, because that image is going to be large. And that means, like when the orchestrator, for example, notices that a pod is unhealthy, it will kill that pod, because the pods are ephemeral. It will kill that pod, and then a scheduler will schedule a new pod to be spawned. Now, imagine if that image was 400 MB. Between the time the pod gets sick and it is killed to the time a new one is found, there's a network aspect to it. We have to download, we have to pull that image. I know there is image policies, like for example, only pull if not present. Yeah, but still, it is a lot for the infra to push this. We just have make sure your application is small. And then another question is it is developed and deployed on cloud-based infrastructure? Oh, there's somebody who's attempting to answer that. Yeah, it is. So it's a cloud-based. Yeah, and then yeah, I think the other ones were commendations. Yeah, I don't know if we have additional questions. Yeah, Marilyn, maybe before I pass it over to you, there's a question.
Yes.
Okay. Yeah, you can go, Tevin.
Okay. I've seen you using Jenkins to kind of integrate the changes to the GitLab account. So let's say I've seen tools like Circle CI. So how does it compare to Jenkins?
Yeah. So Circle CI was actually open source, and it was very popular with the community until they went commercial. So Circle CI right now is commercial. The beauty with Jenkins, it is purely open source, and there's a lot of plugins that can support very many use cases, right? So it is a CI tool. Bamboo as well. There are different tools, as I mentioned. So basically, you go for the tool that best fits your need. So you may not be penalized by a recruiter for having a knowledge on one. I think for them, it is the concept that you understand the concept of CI, and you understand the concept of CD, and you are aware of tools. And in this DevSecOps tools, the knowledge of tools is quite important, because we use tools a lot. Yeah. Yeah, so I hope that answers that, Tevin.
Thank you. Any other question?
Maybe I could ask. For DevOps, we have the ops part, which you have clearly explained well, using the tools and the various packages, the tools used to ensure that the application has been deployed well. Now, for the other side, the dev side, which is more recommended which stack, which language is more recommended for someone to be better positioned for a DevOps career? Is it Java, JavaScript? Is it being a web developer, data scientist? Which side is more recommended?
Yeah. So the DevSecOps methodology sort of like bridges the developers and the operations bit of the software life cycle, right? Now, it is expedient for a DevSecOps engineer to have programming skills, right? But it is not fixed in stone as to which one are the best. But if you have an object-oriented programming fundamentals, you really are good in object-oriented, and of course, you also can logically think out, like you can come up with algorithms, for instance, the better for you. So there is no knowledge, but this I'll tell you. As DevSecOps, we also interact a lot with servers, right? So if you have bash scripting skills, that will do. Now, if you really want to go open source, if you really want to go big, to be a contributor, because we are, as I've told you, we are very huge on tools. If you want to be a contributor of these tools, you would be best if you would learn Go because Kubernetes itself is Go, Flaxseed itself is Go. So you'd find most of these new age tools are Golang native in nature. So if you really want to become a contributor, that is it. GitLab, weirdly, is a Ruby. It's a Ruby, I believe it is a Rust. It's a Ruby implementation. It's built on top of Ruby. So if you want to create a plugin, you have to use Ruby. But if you want to be a contributor, really like you're energetic about enhancing those tools or customizing those tools, I'd say go for Golang, go for Ruby if you're into GitLab. Yeah, I think as you understand these tools, you would know which languages they're made from, and maybe if you want to raise a PR, you would then know I have to have this language knowledge for me to be to really sort of like contribute to the community. Yeah, as most of these tools actually are open source. I hope that answers your question, Gitao.
Yeah, it gives me some a good direction. Thank you.
Yeah, thanks. And I'm loving the questions that are coming here. They're really good questions. I think there is a question by by one of us. It's saying, is it only web apps or Android? I think when I was talking about the cloud native. So I'd say Android is kind of tricky because Android runs on a handheld device, but for web apps, absolutely, you can scale it. There's a lot of innovation around web. There's crazy things. If you come to AWS, you'd hear things like CloudFront. You would hear security items like Impava. You would hear firewalls like WAF. There's a lot of items around web. Web is kind of crazy because it allows people access, as opposed to backends. That backend you can actually have a key, you can actually authorize and authenticate yourself. So web is crazy. Now, where DevSecOps come in terms of Android and web apps is actually that CI/CD pipeline. So maybe, and this is something very, 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 very interesting. Yeah. So right now, you can ship your Android from your laptop to Git. Git, once you've just pushed it to Git, there is a webhook. Jenkins get to be aware of this, and I think I'm really biased on Jenkins right now. But then you can actually do your CI, you can do your what do you guys use for Android testing? I think JUnit. You can use that and then do all the tests, the sanity checks, everything, package your APK, and then push it to Firestore. To Firebase, and then from Firebase it can go to Play Store. That you can create actually that pipeline, right? So there's a lot of fancy things you can actually do with Jenkins and these CI tools and CD tools, that the way it automates things, it's really interesting, right? And it is consistent because you have set it in code. It is compliance as code, it is quality as code, all of those things, it is in code. So it cannot be manipulated by, for example, today I feel like allowing this thing to pass. No. Yeah. So I hope that answers your question. Yeah, I think that answers your question. Yeah, I think, but I really have liked the questions that have come through. Yeah, and I think, I don't know if you have any additional questions, Marilyn.
Yeah, maybe I could make a comment because I know there are guys who have been hearing these things in the previous sessions. I think now we know. I am happy that you mentioned collaboration. I think 2 weeks ago we were trying to teach guys on GitOps, just those commands, branching policies, and whether merge request or pull request, depending on the tools that you're using. But one of the things that I would, I looked at your script, the Jenkins script, and I saw some commands like, Maven build, Maven test.
Yeah.
I think one of the things that I would like to mention to the learners is it will be very difficult for you to do those scripting if you do not appreciate what happens manually. So if you don't know how to build a Maven project, how to convert your .java classes into a Java file, then you'll have a difficult time getting to do that. And that's why even when you are deploying websites on Nginx or Apache, you cannot ignore the process that is done manually, because now when you go to what Peter is teaching us, you will also float. If you have no idea that you have to move the files into the www or the document root folder of your web server, you must appreciate those things so that you move forward. I'm happy that you also highlighted, we can't run away from Docker Kubernetes. Actually, this was the challenge for this. And the fact that these things come in handy. One of the things that I've noted, if you want to become a developer in Kenya, I've interacted with a number of enterprises. I've seen your code, you're writing something in Java. I've seen Spring Boot. I think it is also good that we appreciate that if you go to KCB, they use that. Talk to Coop Bank, they use Spring Boot and Java and all that. So if you want to just plug in, be open to learn those things, because if you want to build a career in our local setup, then you might find that maybe the APIs that are done by the DXL team in Safaricom, as you guys were teaching us during the summit, they are done using Java and Spring Boot. So we need to be cognizant of what is happening and be agile enough to adapt. Yes. So, but that for me, Peter, is just to thank you so much for accepting the call to come and educate us. I feel very educated. I might throw a few tweets today, just showing my transition from ignorance to knowing something.
Thanks. I think Marilyn, you can allow me to, I think to close it there. But I really thank you for your audience. I think the students, I like the questions that came, and I know guys are passionate, and some are still maybe wrapping their heads around what we have showcased so far. But I hope maybe somewhere, somehow, it will meet you, and it will maybe spark something in you, and maybe you would say, I think this is a good thing, and probably maybe you'll pick it from there. But thank you very much for your time. You've been a good audience.